All right, so we are talking about inverse functions today. All right, it's going to be separate from the Unit 5 test. Didn't want to overcrowd you guys, so we're doing inverse functions as its own little thing, and we will be taking a quiz on inverse functions, okay? So today you guys are going to be able to solve, determine or how to find an inverse function, and you're also going to be able to graph an inverse function. Now, we are going to split this up into 2 days, okay? So because don't want to overwhelm you, all right? So, to start, an inverse function is the reverse of the original function, okay? So, an inverse function is the reverse of the original function. Okay? So, that basically means, like, when you're given a function, the inverse is pretty much like the opposite of the original function. So one function is x plus 3. The inverse is going to be x minus 3. Okay? A lot of the operations are going to be the opposite. All right? And one of the ways that you determine this is pretty much you just switch your x and y's. Okay? That's how you determine the opposite, aka the inverse function. Now, take a look at this very first example, okay? You're given a set of ordered pairs, okay? A set of ordered pairs is known as a relation, okay? But a relation could be a function if it follows what rule? Who remembers this from Algebra 1? For a relation to be a function, what does that mean, to be a function?
Greater than 0.
Not quite. So it does relate to the coordinates.
Wait, the x, like, it can't have the same number?
Can't have the same, what do you mean same number?
Like, if it's 1, 2, it can't have 1 in the x and other.
Very good. Did everybody hear what he said? If it's 1, 2, you can't have 1 and something else, okay? So every x has to have a unique y, okay? So you can't have repeating x values if you want the relation to be a function, okay? So look at this very first example. You have 1, 2, 4, negative 2, and 3, 2. Is that a function? No. Do you have repeating x values? No, you don't. So because you do not have repeating x values, that means it is a function, okay? Yeah, you got to look at the x's. The x's cannot repeat. Okay, so it is a function, and the inverse of this is going to be where we switch our x's and our y's. Okay, so if I switch my x's and y's, my inverse is going to be what? 2, 1, negative 2, 4, and 2, 3. That is going to be my inverse. All I'm doing is literally taking the x and y coordinates and switching them. Now, when I look at my inverse, is that a function? No, it is not. And you know it's not because of what reason? It is repeating x's. You have a 2, 1 as a coordinate, and you have a 2, 3. You cannot have this. You cannot have repeating x values. Every x value needs to have a unique one and only y. So if 2, 1, you can't use 2 anymore. You can't use 2 anymore. Does that make sense? Okay? So in order to be a function, your x's can't repeat. All right? And to find the inverse, we just switch our x's and our y's. You guys go ahead and look at the second one and answer those questions, okay? Is it a function? What's the inverse? Is the inverse a function? How do you know? So looking at B, is this a function, yes or no?
Yeah.
Yes, it is. If you notice, you have negative 2, 3, negative 8. None of the x values repeat. So the only time you can find an inverse is if your original is a function. If it's not a function, you do not find the inverse, okay? Make a note of that. If the original is not a function, you're not going to find the inverse. Make a note of that somewhere, okay? Make a note of that somewhere. If the original is not a function, you're not going to have an inverse, okay? But since this is a function, what is our inverse?
4 negative 2.
4 negative 2. Negative 4 3. Negative 5 negative 8. So all we do is we take our x coordinates and our x and y coordinates and we switch them. Is the inverse a function? Yes, it is. How do you know?
But the x's do repeat. 4 and 4.
This is a negative 4.
Oh, gosh. How did I screw that one up?
All right? So no repeating x's. Another way that you can tell if a relation is a function, let's say you're not given ordered pairs. Let's say you're given a picture of a graph instead. Okay? You guys will learn this back in Algebra 1. Okay? Let's say you have this function. I give you this graph. And I ask you if this is a function. Does anybody remember that concept, that rule from long ago?
It's like you get a pen and like you drag it across, and it's not supposed to hit 2 points.
Now, the way you're holding your pen,
It's straight up.
and what's that called?
Horizontal.
Vertical.
My bad.
Vertical. The vertical line test, okay? If you can hold your pencil or you can draw vertical lines throughout that graph and that graph does not hit those vertical lines, if they only hit one time, then this is a function.
Where do you draw your lines? Just anywhere?
Anywhere. So you can draw infinitely many vertical lines and it should only hit one time if it is indeed a function. Okay? So if I give you a graph instead and I ask you, is it a function? You guys will be able to tell me yes or no by the vertical line test, which means it will have an inverse. And we're going to talk about graphing inverse functions in not the next flap, but the flap after. Okay? So, how to find the inverse of a function, okay? Instead of giving you points, I give you an equation. 5 steps. 5 steps. The first step, you want to replace f of x or g of x or h of x, whatever this first part is, you want to replace it with a y. Okay? That's step number 1. So I'm going to take f of x, I'm going to replace it with a y. That's pretty much what f of x is anyway. F of x is y. Now my second step, I'm ready to find the inverse. So I need to switch our x and y. So literally where they're placed, you switch them. So instead of being y equals 3x minus 2, it's going to be okay? This is how we find the equation of the inverse when we're given an equation, okay? So when we're given points, it was simple. We just switch the points. But when we're given an equation, we do have to go through a few steps, okay? So everyone's good? All right. Now our third step, we need to use our algebra skills and we need to solve for y. And I lied, it's not 5, it's 4. Because we're almost done. Okay? So to solve for y, I have to get it by itself. Old school algebra. How do I get y by itself? I add 2 to both sides. And then I divide by 3. Okay? Now the last step is a very crucial step because you need to indicate that that is the inverse. So you need to replace the y that you've now solved for with the inverse notation, which in this case is f to the -1 of x. All right? That notation right there represents inverse. And yes, you do need to make sure that you write it as such, because if you don't, y is associated with the original function. X plus 2 over 3 is not the original function, it's the inverse. So you need to indicate it as such with the x with the -1.
Why is it -1?
It's a great question.
So you just put -1.
No, there's a history behind that, and that was like the one class I didn't take to get my master's in math. So, like,
Got
Be -1 or like will it be negative?
no, it will always be. Great question. It will always be -1. But the f part, that will change depending on what the original notation was of the function. So if it was g of x equals, then it will be g to the -1 of x. Yes.
Before we did that, you said that there was 5 steps.
I know, and then I, like, in the middle of step 3, I was like, actually, it's 4. My bad.
Oh, okay.
And the reason why there's 4 is because I'm not going to ask you to find the inverse unless this is indeed a function. Does everybody understand? You can only find inverses if the original is a function. Do you guys know what 3x minus 2 looks like?
It would be
Oh, it's slope, and then so you like add 2, so there's like 2 on the y-axis, and then up 3 over 1.
So it looks like a, is this a function?
sure.
Yes.
It passes the vertical line test, right? So that's why I'm asking you to find the inverse. So I'm not going to ask you to find the inverse unless it is a function, okay? So that really was like that first initial step, make sure it's a function. But if I ask you to find the inverse, you know automatically it's a function, okay? Let's look at this one together. Then I'm going to have you guys do the third one on your own. What's the first step? Replace f of x with y. And then switch y and x. That's the most crucial step. You gotta switch them. After that, you solve for y. So algebraically, how do you get y by itself? Multiply by 5 because we have to get rid of the 5 in the denominator.
And then you
Subtract
subtract 3.
3. So that'd be 5x minus 3 equals 2y.
And you
Divide by 2. So you get 5x minus 3 divided by 2. And then the last step, f to the -1 of x. So you got to have the notation to indicate that it is the inverse.
That's nice to know they didn't teach you this in college.
Wait. It gets more difficult, doesn't it?
Depending on the function that's originally given to you, that's how difficult it can get. So if you're given like a function that say has 2 x's instead of the 1, then that's when it gets, that's as hard as it's going to get, is depending on the function.
But you're still using the same steps.
But you're still using the same steps. So the algebra part, you might have to do a little bit more manipulation, but the steps are still the same. And if you guys know this is a great example. The original function, you were multiplying by 2, adding 3, and dividing by 5. The inverse is the reverse. So instead of multiplying by 2, we're dividing by 2. Instead of adding 3, we're subtracting 3. And instead of dividing by 5, we're multiplying by 5. The inverse is switching your operations. Do you see that? Okay. I want you guys to try number 3 on your own. All right, so
Miss Anderson, is this one of your more interesting classes?
yes, y'all never cease to amaze me. So with this particular one, okay, same steps as before. We have to take f of x and write what?
Y.
So we have y equals 1/2 x minus 3.
Switch Y.
Switch y and x.
Okay, and now you're gonna add 3.
Add 3 to both sides, so that becomes x plus 3 equals 1/2 y.
And now you're gonna divide by 1/2.
And when you divide by 1/2, that's the same thing as doing what?
The opposite. Multiplying.
Multiplying by 2.
Multiplying by 2. So whenever you divide by a fraction, you really are multiplying by the reciprocal of whatever it is that you're dividing. Okay? So if it was 1/2, we multiply by 2. If it was 2/3, we will multiply by 3/2. Okay? And so what we need to do with that 2, you think?
You have to
Distribute.
distribute it.
You can distribute it. If you did leave it like this, that would be fine as well. Okay? If it's a multiple choice quiz that we give you, we haven't decided what kind of quiz we're going to give you, but know that it could be written like this, but it could also be written as 2x plus 6. Either way, it's gonna be great. And we want to make sure that we include what?
Wait, that's -1.
That's the -1 of x, and that is your inverse. How are you guys with finding the equation of the inverse function?
Is it okay if I like switch those and have the F?
On the other side?
Yeah.
Yes. I usually do as well.
I'm gonna Google what that one means
Oh my
because it's
God.
just aggravating.
That would be awesome.
I've seen it.
All right. Now, when you're graphing inverse function, every function and its inverses are reflections or flips of one another. Okay? Across the line, y equals x. Okay? So they are flips, or you can say opposites of each other, or reflections of each other. Everybody knows what a reflection is? It looks the exact same, but this time it's just across the line y equals x. Across the line y equals x. A few steps here for this. Graph your original function. Find the inverse of it. Graph it. Okay? As simple as that. So let's look at this. The original function, f of x equals -2x minus 3. Now this goes back to you guys knowing how to graph a line. Where's your bomb? Where's your dropping point? Where's your starting point?
-3 on the y-axis.
-3 on the y-axis. So you go to -3. You drop. I'm not going to use that color.
You want us to do it? Would you like us to do it on the big graph or on the little graph right there?
Let's see what you guys got going on.
We got two graphs.
Do it on the tiny one that's in the box. All right. So you start at -3 and then you what?
Go down 2 and 1 to the right.
1 to the right. Down 2, 1 to the right. Down 2, 1 to the right. How do I get points on the other side?
Go up 2 and to the left. 1.
Up 2, left 1. Up 2, left 1. Up 2, left 1. Okay? Erase this extra point here because that was an accident. All right, and let me draw my line. A pretty line. Pretty line. I'm just being extra right now. I apologize. Okay. We got our graph? Okay. So, one way to do it is like it says over here, graph the original function, find the inverse of it, doing our steps, and then graphing the inverse, okay? So, let's find the inverse. What do I need to do to start?
Place
Y instead of f of x.
Replace,
So switch the y in there.
switch, solve. What I need to do from here?
Divide by -2.
And then replace, right? Now this ain't pretty. How do I graph this?
You know it's bad whenever the teacher says this one ain't pretty.
Oh, wait.
I'm being extra.
So that'd be 1 over -2 is your slope, and then -3 over 2 is your intercept.
What did Trey do right there?
I have no idea. Oh,
He
you
just-
put the fraction, like the x has a 1 in front of it.
Honestly, I don't know what that
Yeah,
And the
yeah.
bottom is a -2, so you just made it a.
He basically took that -2 and divided each of the terms of the numerator by it. And you can do that. You can. To add or subtract fractions, they need to have a common denominator, which they do. So you can separate these by saying 1 over -2, because there's a 1 in front, and then 3 over -2, which becomes a minus. Now, that means I have to start at -3 over 2 and then go up 1, left 2, up 1, left 2. It's like I said, this could not be too nice. I mean, if this is a nice little linear equation, then graph it the same way that you did before. Okay? That is one way to do it. Take the equation and graph it. But the way I like to do it, we just spent all that time graphing the original function. And remember, the inverse, you're taking the x and y's and doing what to them? You're flipping them. Why don't you just do that with the points here on the graph? So this point right here, my original y-intercept, which was at 0, -3. If I take 0, -3, and switch it, it becomes what? -3, 0. I'm not changing the signs. I'm just literally switching their places, just like how we did in the very beginning. So then that point of -3, 0 is on my inverse.
Are we going to do that on the other graph, or are we still doing it on this graph?
We're still doing it on this graph. Yeah, we're going to graph it on the same graph. Let's take this point right here. This point is 1, -5. That's on my original function. So what point is going to be on my inverse? -5, 1. So then I go to -5, +1. Let's take this next point. I have 2, -7. That becomes what? -7, 2. I'm literally just taking the points and I'm plotting them. Sorry, switching them and then plotting them. This point over here, it was -1, 1. When I switch it, becomes what? It doesn't. Something happened. Oh, sorry. It's -1, -1. My bad. Sorry. So switch them. It's still -1, -1. All right. Let's take this point. This point was -2, +1. When I switch it, it becomes what? 1, -2. I'm literally just taking the points.
Up 1 and over 2 instead of up.
Because remember, everything switches. Okay? Does everybody see that? I mean, you should, by now, you should have noticed the pattern. Do y'all see the pattern? I'm just going over 2, down 1, over 2, down 1, over 2, down 1, instead of going down 2, over 1. Like I literally just switch them. So now I'm going to graph this line. Graph this line. Bless you.
Thank you. That's cool. You can do a little line doohickey thingy on that.
And we have graphed our inverse. So to graph your inverse, you could do it one of two ways. You can find what the inverse equation is and graph that, or you can take the points of the original, switch your x and y's, and plot those. You'll get the same thing. If you look, there's my y-intercept. It's at -3/2, so -1.5. All right? If I go up 1 and left 2, I get the next point that's on that line. Up 1, left 2. Like, it's there. It still hits. Okay? And on top of that, it's a reflection over the line y equals x. Now, I'm going to draw this line so that everybody can see the reflection. Y equals x is a line that has a slope of 1 and a y-intercept of 0. Does everybody see that? If I were to fold at that line, literally this part will lie on top of this part, and this part will lie right there. Okay? It should always reflect over the line y equals x, every inverse function.
We just made a spider in math class.
Not quite. Doesn't a spider have 8 legs?
I don't know. They're usually squashed before they come out.
That's true. I try not to look at them too long.
Wait, how did we make a spider?
You didn't see all the stuff that where you cross and all that other good stuff?
Dude.
Is that a blank graph?
Yeah.
That's a whole blank graph. All right. All right, for this one, okay? For this one, I want you guys to graph the original and the inverse of
like one that's not super hard?
This is not super hard.
Alright,
It's a challenge, bro.
This one, listen, this is day one. Day two, we're gonna take it up a level. Okay? Day two, we're taking it up a level. So here we go. I want you guys to use the last graph, and I want you to do f of x equals negative x plus 4.
Check that out.
All right. So,
I think I made a mistake. Continue.
yeah, I was say you were over here talking about songs like don't make it too hard. This one was an easy one. This one was an easy one. All right. If I wanted to graph the original function, which is a function, where do I start?
4.
At 4 on the y-axis and go down 1 over 1, down 1 over 1, or up 1, left 1, up 1, left 1 to get that. Okay? Let me get my nice pretty line in here. Not the best, but y'all get my point. All right? No, I can't move it. Okay. So, I can either find the inverse function and graph that, or I can take the points and switch them and graph those instead. It looks like a lot of you guys found the inverse function, right? Yes? So you replaced f of x with y. You switched x and y. Subtracted 4. Then divided everything by negative 1. And it looks like you guys got to the point where you were like, hey, wait a minute. X divided by negative 1 is a what? Negative x. And negative 4 divided by negative 1 is a positive 4. The inverse is the same as the original function.
Check that out.
Remember, inverse functions reflect over what line? Y equals x, right? That line y equals x. If I were to fold my paper at that line y equals x, doesn't the line literally lay right on top of itself?
Yeah.
That's why it's the exact same thing. Okay? The first example I gave you, it had a different slope and everything like that. So of course, when you folded it, it created a brand new line. But in cases like this, the inverse is nothing but the original function. Okay? It literally lies on top of its inverse.
So anytime that there is basically like a negative 1, 1, it doesn't matter where it starts or where it intersects the y-axis, it's always going to be the same thing.
Mm-hmm.
What about if it's like a 1 over 1?
The only time when it's really going to differ is when your slope is something other than 1 or negative 1. That's when your line is going to be like something different.
Okay.
Yeah. Okay. Questions on how to find inverse functions, how to graph inverse functions, or even what a function is.
What is a function?
What is a function? For real, what is a function?
Something for numbers and math.
Something on a graph.
Y'all don't listen to me.
A function.
Y'all don't listen to me. How do we should I say that for the video?
Function is something to solve something.
Functions are important.
That is true. They are
The
important for
inverse
many things.
function is the reverse.
Okay.
I could have even sworn I told you guys to write this down.
No, you said.
I was on this page, and I was talking about what makes something a function, right? And I asked,
That makes
a
a
ver-
function. What is a function?
what is a function?
It's when your x's aren't the same.
It's when your x's are not the same. It's a set of points in which your x's do not repeat themselves. That's what a function is. It's a set of ordered pairs. It is a relation. It's a set of ordered pairs where your x's do not repeat themselves.
That's describing what a function is.
Yes.
No, it's describing what a function is where your x's do not repeat themselves.
Okay.
Trey.
What a function is not is a set of points where your x's repeat themselves. That's what a function is not.
Trey, algebra 2, you take the logical thing and reverse it.
Oh yeah. So everything's
Inverse function.
Same.
No, I really just like y'all just don't